Welcome everyone. In this video, we'll go through an AQA A-Level Chemistry exam question that involves partial pressures and the equilibrium constant Kp. Question details are at the end and are also given in the description. Let's get started. Here's the question. An equilibrium mixture is prepared in a container of fixed volume. CO reacts with Cl2 in equilibrium with CoCl2. All the reactants and products are gaseous. The enthalpy change for the reaction, delta H, is equal to minus 108 kilojoules per mole. The temperature of this mixture is decreased and the mixture is allowed to reach a new equilibrium, which is greater for the new equilibrium than for the original equilibrium. A. The mole fraction of carbon monoxide. B. The partial pressure of chlorine. C. The total pressure of the mixture. Or D. The value of the equilibrium constant Kp. Let's look at each option in turn. The value for delta H is negative, so the forward reaction is exothermic. The equilibrium will shift right to oppose the change applied and increase the temperature when the temperature is decreased. Therefore, the mole fraction of carbon monoxide will decrease. Because the equilibrium shifts to the right, the mole fraction of chlorine, Cl2, will also decrease. Partial pressure is equal to mole fraction multiplied by total pressure. If the total pressure doesn't increase, we can state that the partial pressure of chlorine will decrease. The question states that the container has a fixed volume. There are 2 moles of gas on the left-hand side of the equilibrium and 1 mole of gas on the right-hand side. The number of particles in the same fixed volume decreases, therefore the total pressure decreases. This means that option B and option C are incorrect. Kp is equal to the partial pressures of the products divided by the partial pressures of the reactants. There are no balancing numbers in this equilibrium. These are formally known as stoichiometric coefficients. Therefore, there are no powers in the Kp expression. We have already deduced that the total pressure of this system decreases when the temperature is decreased. We have also worked out that the equilibrium shifts right when the temperature is decreased. The value of Kp is only constant at constant temperature. The total pressure decreases, the partial pressures of the reactants decreases, and the partial pressure of the product increases. Therefore, Kp increases. The answer is option D, the value of the equilibrium constant Kp. Thanks for watching. I hope you found the video useful. Please post in the comments if you have any questions or suggestions. Take care and good luck with your studies.